Welcome back, everyone. Been away for a while. Did a work trip to the US, so I was on long haul flights. Did about 44 hours of flying over the last 5 days, which is never fun. I've asked my family to remind me never to do that again. But good to be back. I haven't done any programming since I've been away. It's just I haven't had the time. Literally, sort of 12, 14-hour days while I was over there for work. So. But I'm back. Actually, I lie. I did some programming yesterday when I landed, as you do. And I've been making progress. So I've been doing some live streams. I'm still unsure how to do this stuff. I'm pretty sure no one really wants to watch me program, but there are probably a few people that find it vaguely interesting if they're learning themselves. But at the same time, I don't know, there are some benefits for me doing this, even if they're not full streams. I've been trying live streaming, but that's difficult with interruptions in the home and a young family. You can never predict when a baby's going to cry or want to be fed, so that's hard. So I'm thinking I might just do videos and see how that goes. It gives me a little bit more control if I need to chop something out in post or if I need to change the way that the flow of the video works. And it also means that I can do this offline, or at least I can do this in in different scenarios where I don't have to have the right setup. Anyway, so for those that have just looked at the video, there is a bit of a series with some gaps in it around me learning how to do graphics programming, and I'm still pursuing WebGPU. I think it's fantastic, so I'm going to look into that more and more. I think it doesn't mean I won't look at Vulkan later. I almost certainly will, but I'm going to build some stuff and actually learn the graphics concepts, because there's a kind of a concept layer cake that you need to get your head around. There are many concepts, and I'm introducing Rust, the programming language, which I'm still learning. I'm introducing an API to do graphics, in this case WebGPU, and then above that there are many sort of concepts around how do you program graphics pipelines, and then above that, how do you represent, the world that you're rendering, for example, or the three-dimensional space, or maybe it's a two-dimensional view that you're rendering. And so there's many layers to this. So I'm sticking with WebGPU for now because I need something, and it is reasonably easy to get something on the screen. So what I was doing was I let's go to the desktop. I had a Let's just run where we got to. Well, this is not where we got to. This is where I am now. Okay, so what I've got now is my very simple app called Simul that renders 100 of these polygons that are 3 triangles each using instancing. I can swap the texture between them by just hitting the space key. The Glenda Space Bunny here is a Plan 9 reference for those of you that are into your Unix and Plan 9 and Ken Thompson and Rob Pike, those guys. Anyway, and then what this overlay on the top right-hand side now represents is the depth map. And this was something that I was really struggling to do. In fact, I had to cheat to get this done. I've learned a lot, but by cheating, I'll show you what I mean by cheating. Anyway, and so I spent probably 3 or 4 hours on trying to get that going. And rather than just kind of continuously spin my wheels, I referred to the implementation that the tutorial writer provides. And my implementation of this has kind of diverged quite a bit from what he's got in his tutorial, at least in parts. And so it's not identical. I couldn't just do a one-for-one copy-paste, but it was something that I could just refer to and see where I was missing things. And I'll take you through that just briefly at the start of this video. So we're done with depth mapping now, or depth maps and depth textures and rendering that, at least for now. So that's all cool, and it should work with resize and do all the right things there, and yeah, great. So that's where we're at. Now, for those that are just following along, the tutorial here is excellent. It's not complete, but I kind of like that. I like that there are a few gaps that force you to kind of think critically and fill it out for yourself. And I'm following along here. So if you go to the depth buffer part of the beginner section of the tutorial, the challenge was the depth buffer is a texture, so let's render it and let's put that on the screen, which is what we just did. What we're going to start next is model loading. I haven't even looked at this, folks. So there is a temptation for me to kind of like go through the tutorial ahead of time and then kind of work out all the kinks and work out how to solve the issues, and then just kind of replay that for you on a stream or on a video. And I'm sure there are other people that do that, but firstly, I'm not that organized, and secondly, well, I could be, but I just don't think there's no integrity there. Unless, of course, you're honest with your audience. And I've done videos like that before, like the rendering one I did ages ago. There was a ray tracing one that I did ages ago. I did that where I had a clear tutorial. I was translating that into Rust. I'd found someone else's implementation, and I was getting some inspiration from that too. And I was also working ahead of the video where I'd actually work on it and sort of solve the problems and then get that going. But I don't want to do that here. I want to kind of just show you how a beginner in both Rust, programming, and WebGPU kind of works this stuff out. All right. But let's go back to the depth buffer. So we got down to, so the depth buffer bit of the tutorial here was really just trying to solve for the fact that the draw order of these polygons wasn't always right. And so you use this thing called a depth buffer. So for every pixel or fragment that's drawn, or texel, I guess, and I'm not clear about exactly how all those things map. Like, is it texel a pixel and a fragment? I kind of guess it probably is, but I don't think it always is if you're doing MIP mapping, for example. Or maybe it is, I'm not sure. But anyway, so for every pixel or fragment that is drawn on the canvas or the surface or the screen or the view or whatever you want to call it, you then just have a simple way of doing a test to say, is this pixel in front of one that might already have been drawn? And if it's already been drawn, then you just you draw it on top, I think, or you do a depth test. You say how far away from it is. Actually, we'll get into that. So there is a process anyway where it allows you to kind of check against some of the other things that have been drawn, and do a test and say whether or not it should be drawn on the screen or not. And the idea is that you're only drawing things that are in front of objects, so you're not drawing things from behind. So that should save time, but also give you the right draw order. And so they talk about sorting and all this sort of stuff. Now, so we got down, we did all of this, and we built. So what you end up doing, let's just refresh ourselves. You end up building another texture. And a sampler. So you've got a view. Sorry, this is your view, and then you've got a sampler. Okay, and you put that in a texture object, and you use that in. You attach that to, where was it? In the render pass. You link that to the stencil depth stencil attachment. Okay, now this texture is created during the render pass. Okay, so like if we go to our friendly ChatGPT, I'm using a depth texture in a render pass in WebGPU using WGL for Rust. When is the texture created? And it's when you set up, okay. That's when you create the texture, but when is the texture, when are the pixels in the texture, in the depth texture, written to the texture? Yeah, so within the render pass. Okay, so you when you set up the render pass, you specify the depth texture. Okay, so if we go to our code here, render pass. Okay, so this was our render pass, and you specify the view and the types of operations that are supported. Oh my goodness, go ChatGPT. All right, so the descriptor tells the GPU that the depth texture should be used for depth testing and writing. Okay. Your render pipeline includes the depth stencil state that configures how the depth testing will work. The state includes settings for depth comparison functions. So if we go back to render pipeline, here we go. So the depth stencil here is, so it's a texture depth format, which we've defined in our texture module. Depth right enabled true. Depth compare if, so let's look at what this thing does. So we'll go to WGPU. What does this thing do? Function passes if new value is less than expected value. Oops. Okay. Rendering. During the execution of the render pass, as your draw calls are issued, the depth buffer is updated. The GPU writes to the depth texture based on the depth values of the fragments being processed. The depth test determines whether a fragment should be written to the color-based buffer based on the depth value compared to the existing value in the depth buffer. Okay, so go back to our render pass. So we'll go and have a look at depth stencil attachment. So this is an example of what I mean by you have to have so many concepts in your head and hold them all there. Okay, the depth stencil attachment. The view to use. The view to use. Oh, hang on. Is this right? Am I looking? How about I go to the right? Not that it matters, but I think I'm using an older version of the library. This has just been updated 10 days ago. I might as well look at the version I'm using. Okay, so let's try that again. Oops, wasn't that, was it? Let's do depth stencil attachment. View depth ops, stencil ops. Okay, so the texture view. What operations will be performed on the depth part of the attachment? What operations will be performed on the stencil part of the attachment? Now, we haven't looked at stencil, which I think you can use for shadows and other things and the outlines. But ultimately what we're doing here is we're saying that the depth ops are allowed to be operations. These operations are allowed to be load or store. So the store up where the data will be written to through the where the data will be written to through the attachment. Yes, so we want to store it, and then load up is clear 10. Loads the specified value for this attachment in the render pass. Primary over clear is significantly cheaper. Okay. Right. So this is what defines what happens when the draw calls are specified, or when the draw calls are made. Okay. So this it's basically this render pass that creates the depth texture. Okay. And this was the bit that I wasn't really getting before. So the depth texture just is nothing really until it's created. Like yes, you use the texture module to create the texture and all this sort of stuff, but it's basically empty until you do a draw. Sorry, you do the first render pass, and all the draw calls populate the texture. Now then, the idea was, well, how do we then reuse that texture? And I was in the last stream, I basically had created a depth scene struct. because I needed another object to kind of hold all of the state for what I wanted to do with the depth buffer overlay. And so I needed new texture, and critically that texture needed to be a non-comparison texture. So I had to change my create depth texture function. And I created a Boolean here that just said whether it should construct a comparison depth texture. This is all pretty hacky, but this is how I did it. I assert that it's the width and height. Oops. There you go. It's a bug. The width and height aren't 0. And then basically I say, look, the sampler is going to be different if it's a comparison texture or not, or depth texture. If it is, then we do stuff like pass in we have compare being less equal, and we have mag filter, min filter, map filter being linear, linear, and nearest. If it's not, which is the case for when we're rendering a depth texture, we don't want that. We want this block. Then we do, we have no compare function, and we use nearest, nearest, nearest for all of these. Anyway, so that returns the texture object, if you like. And then we have a separate one for the depth scene. Then we have a separate bind group. And the bind group still uses a, it still has 2 entries. And the first one is for the texture itself, the view, and the second is for the sampler. Then, no, that's what this is, yeah. And then I create a separate shader called depth shader, which we'll look at in a sec. Create a separate pipeline layout, then create a separate render pipeline. And this render pipeline doesn't use a depth stencil, right? Because it's not trying to render depth in any way. It's just taking an existing depth texture, hopefully, and rendering that to a surface or a view. So originally we had that in the other pipeline, but in this pipeline we don't need that. And largely a lot of this stuff is the same. We still use a vertex buffer and an index buffer, because we're still rendering triangles, but what we're doing is just rendering 2 triangles to render a quad at the top of the screen there. And so I originally set this up, and so this is all fine. And if you look at depth scene, I store that in the simul app as well, so I've got a handle on the scene itself. And then I create the scene in the constructor for the app, right? And so that's how that works. Then later on, I use the scene. Okay, and so one of the places I use the scene is in the resize function, because I need to reconstruct the depth texture and reconstruct the bind group for the depth texture. And that was a bug that I had. I wasn't recreating the depth texture, and I wasn't creating the bind group, and so it wasn't getting displayed. And I think resize events happen as well, even at instantiation. Like when we first run the app, I think we get a resize event, for example. So, print line, we have a resize event. Okay. So if we were just to run the app now and not resize the screen, we'd probably see that fire. Yeah, so all that happened is the screen loaded, and I have 3 resize events. Now, whether or not that's good or not, I don't know, but that's the case. So so we need to do that, and then where else did I have? Okay. In the render pass. So render is called when an update is requested by Winit, So there's an event where there's a redraw, requested. So that's when we call render. And I originally just had one render pass. Now, what I needed to do was create another render pass. And I was trying to avoid that because I'd created a render scene, a depth scene, and I had the pipeline and all the other bits and pieces that I needed there. And I thought I could just reuse the same render pass, and I couldn't. So I needed to, and I was trying to remember why I couldn't. What was the reason? It might have had something to do with. So I have a different. Can't remember. It'll come back to me. But anyway, I had to create a separate render pass, and so I did, and it's largely the same, except what's different here. So here I've got a depth stencil attachment. Here I don't have a depth stencil attachment because I'm not creating any depth textures. I'm not doing any depth testing. Okay. Now we try and draw the depth buffer texture, rendering depth buffer scene. I do use the same queue and the same encoder, but I had to do 2 render passes inside of our render method here. Now I kind of got all that working, and I was getting a black screen. And so there were some issues with my shader. Originally, I didn't know any of this stuff. So when we do the fragment shader, all I was doing was sampling the first element of the texture 2D. So I was basically, sorry, I was, okay, let's have a quick look at this. So, so there's 2 bindings. There's the texture view and the sampler, right? And originally I was using texture sample, and I think I was referencing it as the 0th element of texture sample, assuming this was like a 3 tuple or like a vec3. And then I was just, because I wanted grayscale, I was just saying, okay, that in RGB with an alpha of 1, render that to the screen. And what I wasn't doing this .x thing anyway. I wasn't referencing that way. And also I wasn't doing this calculation. Now this calculation, I still haven't gone into the detail for why we need it. I mean, I understand, I think, why we need it. And it's something to do with the fact that there is well, should we think about this now? I don't know if we should think about this now, but basically this was, I think it was linearizing the depth information, because the depth information was non-linear because of the way that the view projection works. And so you sort of have to do this, I think, to undo the view projection type warping in the scene. But anyway, don't quote me. It's not something along those lines. So you get like a good graduation from sort of white to black, right? Anyway, we'll go through that maybe another time. I do need to understand this better, because you set near and far, and you do this very simple kind of transformation on it. Anyway, so I got that from the sample that they give you in the tutorial solutions, and then I still wasn't getting what I wanted. And what I realized was that I was creating a depth texture in the first render pass, and then I was creating a new depth texture in the second, but there was no information in that second texture. And what I realized was that I'd made a really simple mistake, and I wasn't writing to the depth texture in the depth scene. I was still writing to the depth texture in the first pipeline. And so what I had to do was update when I do this first render pass that the view is depth scene, depth texture view, which meant that I'm actually writing to the depth scene, depth texture, which is what's used when I render here. And so then that started to show the depth texture. Anyway, I did all that in a jet lag state yesterday, and I committed to the branch I was working in. And so we now have a depth texture rendered appropriately. At least I think it's appropriate. I think it's correct. Okay, so enough about all that. So how about what we do now is we move on. So we're at the end of the beginner tutorial. This is quite a long one, but maybe we can get it done. I guess we'll see. So this is all about model loading. Okay, so far to date, what we've been doing is we've just been hard coding vertices and indices here. Okay, so these indices are used in an index buffer to efficiently draw the triangles based on this vertex information. So I get all that now, and that's all great. And that works. But I guess the idea is that this is probably a more efficient way to do it. So let's take a small break, and then we'll jump back into model loading in about 2 or 3 minutes. All right, we're back. So let's get started with model loading. Now, I know a little bit about model formats and model loading, but certainly I've never done a model parser or anything like that. Hopefully that's not what we're doing here, but I also downloaded a couple of models from, I can't remember where I got them, somewhere off the internet. What could go wrong, right? Blender.org. Okay, well, anyway, this was a pretty cool model, so we might try and load that at some point in the future. So let's get cracking into it, shall we? So up to this point, we've been creating our models manually. When we've got lots of polygons, that won't work very well. So we're going to modify our code to leverage the obj model format so we can create a model in software such as Blender. Great, and display it. Our libRS is getting pretty cluttered, so let's create a model RS into which we can put our model loading code. Sure. You'll notice a couple of things in here. In lib, we had vertex, but here we're using it as a trait. Interesting. We could have had multiple vertex. We could have multiple vertex types. Why would that matter? Why would multiple vertex types matter? Making it a trait will simplify, allow us to abstract out the vertex buffer layout creation code. Oh. Is that because you have different vertex buffer layouts depending on the type of vertices you're trying to display? The normal field. Okay, cool. So what have we got? We've got a trait. We're doing a model vertex, which is position, text coordinates, and a normal. And these are all, I guess, vec3, vec2, vec3, ultimately. But we're using arrays because we need to be able to pass these to and from a shader. So we're using the C representation for the memory layout for these structs. And we're deriving clone, copy, debug, bytemark pod, bytemark zeroable. And then we implement vertex for model vertex, which returns a vertex buffer layout, the static lifetime. What's static lifetime mean again? What does a static lifetime mean in a Rust struct? Oh no, I mean in a return type in Rust. The data referred to by a reference is guaranteed to be valid for the entire duration of the program. Returns an owned type. that contains static references within it. Okay, so maybe this stuff. Did we use vertex buffer layout before? Vertex must have buffer layout. Yeah. Okay, that was right. That was how we interpret basically the memory. Yeah, the memory associated with the vertex buffer. Okay. All right, let's start our timer. We'll do half an hour and see how far we get. So we need to create a new file called model.rs. Okay, and then we'll do a trait that returns WGPU vertex buffer layout yep. Geez, what did I just do then? That was weird. This new keyboard is killing me. All right, so we've got let's just implement it first. Oh, hang on. No, let's not do that. Let's do pub struct model vertex pub position 3 array of float 32s. Oops. Text coords. There's only 2 of those. And then normal. Okay. And then we'll import the. So we've got a trait called vertex, and then we're implementing vertex for model. Text buffer. I use this to do macro. This guy loves his to do macros. Why is the syntax highlighting here more dim? It's weird. Is it telling me something about Rust analyzers trying to tell me something? File not included in module tree. Is that why? Sure. How? Yeah, well, that's shit. Mod model. Does that suddenly make it all go up? Yeah, let's see. I guess it's nice because it visually shows you that it's not being used, but it just looks crap. Anyway, so we've got a trait. I thought traits were like, hang on a second. Do we have to implement traits? Traits. Oh man, this is my Rust knowledge showing. So, how do you? Okay. How do you implement a trait in Rust? Defining the methods. Implement the trait for a specific type. So the type is model vertex, and you're implementing the trait for that. Okay, it's sort of backwards. I'm used to Java and C#, where it's kind of more like an inheritance type thing. Not inheritance, it's more, anyway. All right, so we've got a model vertex thing that also has these members, but also has a describe function as well, method. All right, you'll notice a couple of things. We had a vertex, okay, blah, blah, blah. All right, great. Now we need to define our vertex buffer layout. Well, I guess we can just copy it from here. Let's just start here anyway. How does Vim work? Can I just yank that and then put it over here? Probably not. Can. Well, wouldn't you know? So that's probably not going to work. But why? Because we don't have... Yeah, cool. Excuse me. Oh, that's not what I wanted to do. All right, so what's happening here? Array stride. And so we're, every time we step through this in the memory layout, we want to step through by the size of this struct. Step mode should be. See, what's step mode? I'm so curious about these things. Vertex buffer is indexed by vertex. WGPU invokes the vertex shader entry point once for every VI pair, where V is drawn from vertices and I is drawn from instances. Buffers whose step mode is vertex use V as the index into their contents, whereas buffers whose step is instance uses I. The indicated buffer element then contributes 0 or more attribute values based on this attribute list. It's kind of cool when you get into the detail of how this stuff works. It starts to make sense, like why was this called an attribute? You can visualize the results as a matrix with a row for each I and a column for each V. So V by I. V and I are symmetrical. Key difference between V and I is that the line and triangle primitives are built from the values of each row. Yeah, sort of makes sense. Okay. But anyway, here we're missing stuff. We've got another attribute, don't we? So we've got the same vertex attribute. Position and tech chord. So we'll pass in a normal, I guess. I presume that's what that's for. Offset will be mem size of 5. Oh yeah, that's where it starts. Okay. F32 5 as buffer address. Shader location is 2, and the format, whoops, will be vertex buffer layout. Oh no, vertex format. I mean, float 32 by 3. Okay. So position, oh hang on, is that right? Yep. Position of vertex, texel coordinate inside the texture, and the normal. And I guess, is that a normal to the surface or a normal texture normal maybe when you're doing something funny with lighting and textures? Don't know. Guess we'll find out. All right. This is basically the same as we added a vertex for normal. Yep. Remove the struct in live as we won't need it anymore. And we use our new vertex from model for the render pipeline. Sure. So we don't need this anymore. How sad is that? Oh, but we do need this stuff. Didn't do that. That needs to be on. Am I missing? Oh, right. Let's fully byte muck and byte muck. Okay, that should work, right? Nice. 6 implementations. Wow. All right, but we go back into here and we get rid of all this. Keep that like that. And then see where it all breaks. So it should all be model vertex now. And we'll need a normal. Use model text. So if I don't do that, so none of this works anymore because vertex has 3 elements to it. But what's it complaining about? Size of the values can't be known. Expect struct variant or union type. Found trait vertex. Interesting. So what we might do is we'll do git add, I will add model. What was different about texture? Git diff. Okay, yeah. Git add source texture. All right, we're working on lib. Cool. And then where else are we failing? Down here somewhere. Makes sense. But what was the error we're getting here, just out of interest? Trait bound din model vertex, no unit, no uninit, sorry, is not satisfied. No uninit. Just out of interest, what does that mean? No uninit. I love how vague it can be with ChatGPT. It's usually pretty good. It's not, no, is not a stand. Oh. Right. Trade pod. All right. Instead of getting totally sidetracked, what we'll do is we'll go back to, we need a zip file. With that all in place, we need a model to render. If we already have one, that's great. I'm going to put this model in a new res folder. Sure. But I like assets. I'm going to keep it in assets. Guess we'll have to is it this one? No. Where did I download that file? Zip file, save as, in development. Oh my god. Small dev source assets. That's a zip. Annoying. Small. Extract it. That's great, it's empty. Well, that's helpful. What? How is it empty? Huh? Extract all. Did it not finish downloading or something? Oh, it's an invalid zip file. It's helpful. Zip. View raw. Oh my god. Are you serious? Can I just copy the link here and then let's go old school. Have I got wget installed? Wget this thing. Unzip. Have I got unzip? Oh my god. Okay. How much easier was that? Did it actually work though? Oh, I bloody put it in the wrong spot. Not so much easier. Put up here. Oh, and then there was another one. PNG. Cube diffuse. Ooh, cool. Cube diffuse. Part of me wants to put like have textures and boom. Oops. Shade it. Yeah. Glenda. Where was Glenda defined? I mean, does this just work? I guess we'll find out. Assets. Okay. All right. Enough mucking around there. So we should have a cube model now, which looks pretty complicated. We don't need the zip. We've got a diffuse, we've got the texture, we've got a normal map by the looks of it, we've got a material something or other, which references the normal for a bump map and this for the whatever KD stands for, something diffuse. Anyway, the texture. Interesting file format. Anyway. 7 minutes, right. I'm getting so sidetracked, aren't I? Let's go back to accessing the files. Great. When Cargo builds and runs their programs, it sets what's known as the current working directory. It may differ depending on the project structure. Following code. When loading our model, we could use this path and just append that. That's fine, but if we change it, right. I'm going to fix that by modifying our build script to copy our res folder to where Cargo creates our executable, and we'll reference from there, create a file. Oh my god, are you serious? Apparently. Where does build go? Same folder as Cargo. Oh, so it needs to go up in here. Builds. Just going to copy this because I'm too lazy. And then we need a build too. So git add build. Yeah. Git status. Okay. When you put build in the same folder, it won't run. If you don't, okay. So what's this thing meant to do? Oh God. So we're missing anyhow. I'm a bit nervous about just doing this, but let's just do cargo add anyhow. Cargo add fs extra. So we're using different versions. Which, yeah. 0.3, yeah. Okay. Git add, sorry, cargo add glob. Okay. All right. I don't need to be in source. Why am I in there in the first place? It won't build. Oh, cool. Unresolved import anyhow. Yeah, great. Dependencies. Okay. We're not supporting WASM yet. I do want to get WASM going at some point, maybe for a simpler project. I mean, this is already very simple, but all right, by design, you can't access files in the web browser, I suppose. Use those files up using a web serve and then load those into the code using HTTP requests. We'll create two functions that load text and binaries, respectively. So this is in all right, so I don't think we need anyhow. Do we? Oh yeah, we do. Oh, but this is all in. If I'm using a request to handle loading the requests. Request. Oh my lord. That I just don't want to do that stuff. Accessing files from WASM. How much of this do I actually need? None. Oh my god. WASM just adds so much web complexity and overhead. It sort of defeats the purpose, I thought, of trying to do something cleanly. By design, you can't access the on the blah blah blah. I wonder if I really want to do this. Oh my god. So build doesn't even run. Use anyhow. Copy options. Print line. envar outdoor. Copy new. Probably permissions or something, is it? Jesus. We'll do another 30. This looks messy as hell. Let's try and get... I'm just going to do it and just try and hope that it works. This will have to be in source, I presume. Resources. And then I'm just going to copy paste, because why would I bother? Load string. Sure. So we need location as well. Oh. Mod resources. Mod resources. But build still doesn't work. Come on, Rust Analyzer. Why is it so slow? It's because of the Learn GPU. Oh, it's because I've got that in there. Let me remove this. And let me remove this. Okay, and let me restart now. Restart. Oh my god, hopefully that's faster now. So build doesn't work, great. It's great, but like this build script doesn't work. I'm just going to do a shaders folder too. I'll do Wigstall. I don't use challenge shader anymore, do I? No. So let's get rid of that. So what are we doing? We're adding git add cargo, git add, git delete challenge shader. Oops. Git remove. Git remove depth shader. Git remove data, git add source resources, git add source wiggle, where are we now? Modified lib, git add source lib, of course. It's going to be a fairly large change, isn't it? It's all broken. So I would hope that at this point we can compile, but we can't because build's broken. Let me just see if I misread this stuff. To copy our res folder to where cargo creates our executable. Okay. Add the following. Anyhow, fs extra. If I have a build.rs at the top level with cargo, how does it import, how does it know how to import other Rust libraries? Build dependencies. Really? Build dependencies. It's all this stuff, wasn't it? Standard env. So it's these things. What? Res. Source assets. So assets needs to be up here. Git status. Moving shit around everywhere. So git add build, git add cargo, git delete, remove source assets, git remove source assets, git add assets, git status, build as well. Huh? What are we ignoring? Let's ignore, git ignore. Okay. Oh, it's all managed up here, isn't it? No? Anyway, where are we? WGPU dev. All right, so we've got all the bits that we need. I think it should build now. Let's see. Great. Good. Well, we're getting the right build errors now. Oh. I misread the frickin' stuff. That's so embarrassing. We didn't need any of that. So it was right from day one. Don't need that, or that. That all just sits up in oh, did I break everything, did I? Config if. Thought I had that. That is right. So cargo builds. Okay. Undeclared crate or module config.if. Config if. What is config if? Use config if. Let's grab config if then. So we need to do cargo add config if. Great. I have no idea what config if is, but hopefully that solves that. Come on, Rust Analyzer, catch up. What else is this complaining about? Anyhow, right, so it does need anyhow down in there. I feel like I'm doing something wrong here. Or maybe anyhow wasn't required by build? No, it is. I don't know. I do want to get rid of these warnings as well. Okay, good. Okay, we do load string, right? I think. So resources gives us these load string and load binary functions. If config, yeah, that's funny. If origin ends with learn GPU. Oh, this just gives me, this just doesn't, I just don't like this at all. Anyway, I guess that's the beauty of web. That's why I don't do web anymore. I haven't for a very long time. Oh, cool. Include bytes is gone. Interesting. load binary. Result evacuate. What does this thing do? Slice. I wonder if we do that, just to include binary. Or load binary, sorry. Load string. Read to string. Let's try. Was it load binary? Load binary. What's going to happen there? It's not. Async. How's it used? So it automatically creates it to a converts it to a slice. Or maybe not. Anyway. Cool. So that should mean that our textures are copied appropriately. So we have a problem casting because it's the wrong format anyway. All right, cool. So Goodness me, that was a little bit of an excursion, wasn't it? So what we're going to do now is fix the model loading. We're going to use something called TOBJ. Cargo add tobj. Tobj. Tiny object loader. Cool. We need async, do we? Oopsies. So let's do. Huh? We need this thing. I wonder if we could just do this though. 402. If that just works magically. We need to put it somewhere. So in our model RS, we'll create we'll do a pub model, pub struct model. It has meshes in it, which is a list, a vec of mesh, which we haven't defined yet, and materials, which is a vec of material, which we haven't defined yet. Cool. And then we'll create those pub struct mesh, which has a name, vertex buffer, has an index buffer, has num elements, unsigned 32, and a material, which is a use size, a number. Interesting. And then we'll have material. Also has a name, diffuse texture. I wonder why it's called diffuse. It's used everywhere in this tutorial. Pub bind group. Interesting. So material has a bind group as well. Bind group. Been working at Microsoft too long. Keep typing Bing. So we need use cannot find type texture in module texture. texture does this? Can I find module file, model texture mod? Eh? Shouldn't need it. Use texture. Right, that should be correct. Okay. All right, so we've got a mesh and a material. We've got a model, which is a list of those things. We've got a bind group and a texture. Okay. When using textures in WebGPU, why do people call them diffuse textures? What's the reference to diffuse mean? They're referring to a specific type of texture that represents the diffused color of a surface. All right, cool. Albedo. Basic color information. Huh, cool. All right, so we go back to our little thing here. We need a function to load a texture. Whoops, I just kind of mucked around with that, didn't I? Let's go back to resources then. We'll do a pub async function load texture. Serves me right for trying to go ahead, doesn't it? So we need a file name, device. Really? A queue. Returning a texture. Oh, texture. Load binary. So it still uses load binary, but then it does texture from bytes, device queue data, and then file name. That's what it returns. Cool. So we'll do load texture back in here now then. You know what? I'm just going to leave it for now. Actually, I see what it's doing. Oh, that's cool. So we can just do this. So let tree texture equal resources load texture assets happy tree device queue, and that's it. But then we'll need to await it. Await unwrap. Can I just do await question mark? Probably not. Unwrap. Cool. So it's basically the same thing. We'll call it Glenda, space Glenda. Cool. All right, so that should be right. Get these textures straight out. Cool. All right, that does simplify things, which is nice. Then speaking of textures, we'll need to add a function to load a texture. Seems to work okay. Oh. Right. So the whole point of this, we do need to know the file name. As include bytes requires that we know the file name at compile time, which we can't really guarantee. Still need to know the file name. Mesh holds a vertex buffer and X buffer number of indices. We're using usize. Be index materials when it comes to time draw. With all that out of the way, we can get to loading our model. Sure. I guess that goes into here, right? I don't want to write this by hand. Boom. Productivity. Maybe not. Where does this go? Wow, some code here, isn't there? Where's load model used? Load model goes in resources. So material has something called diffuse texture. Oopsie, where am I? Which is a texture. Load texture wants a string. Diffuse texture is a texture. Object. Should be name, right? Maybe. This doesn't look right. Object materials, vector of materials. Is it? Don't think that's right either. Should be a file name. Well, I mean, let's have a look at one of the models. It'll be in the material, won't it? Cube normal. Cube diffuse. Load texture needs a file name, not a texture object. Rendering a mesh. Before we can draw the model, we need to be able to draw an individual mesh. Oh my god, sure. Before we can render, so we want to put this inside of model RS, apparently. What does it do? So presuming that works, we get a model. So we can draw a model. Yeah, complex code that I'll need to go through. We could have put these methods in int model, but I felt more important to do the job, blah, blah, blah. I didn't remove the render pass. No, I certainly didn't. And depth versus vertices. I didn't move any of that stuff. Okay. Render pass. I didn't get rid of it all, but should I have? Okay. So once we've got the camera bind group, we have to draw mesh instanced. Wow. Cool. Self obj model meshes. Where's obj model? Oh my god, he makes this. Whoever wrote this makes it a little bit confusing. Like, it doesn't need to be that confusing, surely. Draw meshed. Like, do we need to get rid of all of this? I guess so. Like, is all of this redundant now? But we need to load this in our constructor. Yeah, this is going to get messy. A little bit ambitious trying to get all this done, but hey, let's just get going. Do cube obj. And we need to put that in. We need to store that in our struct. Wherever our struct is now, I'm completely lost. Simul. What's it called? Obj model. Obj model is, what is an obj model? Hopefully it's as simple as this. But what does that return? Let's find out, I guess. Obj model. It's a WDP dev. Oh no, it's a model. Okay, good. Alright, so we put that in model. It's bigger than the previous one, so we're going to need to adjust the spacing. Yeah, sure. Following state new. Render pass. So we still set, what do we do? What am I doing? So we still need to set the bind group, the camera bind group for the camera uniform. Then we do this draw meshed instance by passing in the object model instances, meshes. Interesting. Our new model is bigger than our previous one. I was still getting heaps of errors though, or two. Depth, so it's the vertex buffer. we not need vertex buffers anymore? Feel like we do. So the vertex buffer, like the model, actually we just did this big thing here. Let's check this out. So what does this thing do? So it loads the models. So loads materials. Creates the bind group and does all the things. And creates all the meshes. And the text coordinates. Creates the vertex buffers. Does everything for us in here. So that's annoying. Vertex index does everything there. I think I need a different vertex class because I still want to be able to just draw my quad. It makes sense for all the models, but what about the other things I want to draw? It makes sense that this is going away, which makes me sad, but you know, that's the way it is. Oh, we don't need indices either. But we still need a concept of like a simple I don't want normals, do I? So yeah, we don't need this. Do we need number of indices? I guess not. So that's all been taken care of. We don't need vertex buffers anymore, or index buffers anymore. It's all been done by the model. Don't think we need any of this. Simul. Yeah. Don't think we need any of this anymore. Vertex description in the render pipeline. makes me sad. Depth vertices, we still want that. Or should we do something where... But it says it can't be known at compile time. Model vertex cannot be known at compile time. The trait size is not implemented. So we've just got all this stuff in there for depth. Now we're going to take it out. So annoying. Well, I mean, I think we just need to have a different vertex class here. Keep our struct. So what did we have? GitHub. Just keep it all working together. Dev. Source. Lib. So we had struct. These guys. We'll just rename it to something else, I guess. Impl vertex 2D. And I'll call this 2D. Okay. This will be 2D for the depth pipeline. Okay. And then eventually we are keeping vertex 2D around for the depth buffer rendering. Eventually this should be made consistent for with the other vertex, with the vertex implementation used to render models, question mark, don't know. Alright, so we've got something that doesn't look like it'll break horribly, but we don't have spaces, so let obj model, so we're going to need to adjust the spacing. Where are instances defined? Instances. Const space between 3.0. So this stuff should change. God. What is wrong with me? Like, get rid of this. Yeah. Num instances per row. It's like instance displacement's not used anymore. Cool. Let's see what breaks. Not sure how I feel about all of this. It's a pretty big change. There's a lot of code in here that I've just copied and pasted that I need to stop and read and understand as well. But, you know, even though there are gaps and holes in this tutorial, that's kind of a cool thing about it. Sort of, you need to be understanding the basics to be able to get anything running. Let's see what breaks. I'll be very surprised if this actually renders and works. Of course it doesn't. Yeah, it's probably around that thing that I just did. So 531. All right. Load texture. So it should be that, right? Any references to assets now shouldn't be there. Oh. Unwrap on an error value. The system cannot find the path specified. So, questions. Is it copying everything out of assets correctly? Paths to copy. I guess, do we do target, debug? Where does it go? Build? No. Target, debug. Paths to copy out. Where's out? What is out? Outdir is does it print it? Like, is this, how do I find if this is being run? Cargo rerun if changed. Oh, whoops. Assets. Maybe it never runs. Oh, I guess that... Really? What is build? See, I don't even know how build is used. I better not interrupt it. Cargo build. Cargo run. All right, so we got a build problem. 531. Five, 3, 1. So it can't load the texture. It's probably because happy tree isn't copied, I suspect, but we don't know. What is the error? Because we need to find the error. System can't find the path specified. Okay, so shaders look fine. Guess we'll find out about that. Why can't I just do that? Okay. Well, build RS. Code user specify. Anyhow, result. It's an error. So outdoor. Okay. What is outdoor for cargo? For a dev build, what would outdoor be? Interesting. What are we doing? Looking for a target. So target, debug, build, create is create name hash. What have we got in here? GPU dev. GPU dev. BAE. Build script. Definitely not. So much crap. I don't know how the build thing's working. And I think that's the source of the problem. Want all these copied to whatever outdoor is, and then what a copy override is true. And I'm not sure that's working. So if I was just to say touch, I don't know if this cargo run. Rerun if changed. Cannot find the path specified. Result unwrap. When unwrapping this, it gets an error. So can't find happy tree. So load texture. Where was load texture? File name. From bytes. Device data. File name. The question is it failing here? I guess we could just print this out. Print line. File name in load texture is file name. Name. Not a function. Of course it's not. It's a macro. We're well past our 30 minutes, aren't we? So file name is happy tree, and it fails the very first time. So load binary would fail. What is, see, outdir is it'll be env outdir. Let's see what happens with that. Apparently it's that. So we were kind of going in the right direction. It's got assets in it. So it still needs assets in the file name. Does it? bit weird. Assets. So it copies the whole directory with it. See? Assets. Happy tree. It's there. Happy tree PNG is there. Space Blender is there. All our things are there. So it should be able to load it. We do from file, yeah? From bytes, from image. So from image, hang on, from bytes. From bytes. Load from memory. So it's load binary. It's this load binary. Is this what's throwing an error? So if I do load, whoops, file name in load binary is path. That'll be path. Yep. Let's try this. Path is obviously, I can't do that. No such file. Assets. Huh? Is it just the weird backspacing bullshit? No. Res. Where did res come into it? Out res. Oh God, don't tell me. Assets. What the hell? Res assets. Out res assets. Assets. Let's see. All right, 1 second, folks. All right, we're going to continue and see if we can debug this res issue. Okay. Where did res come into the whole picture anyway? So we've got assets here. Does resources add, it adds res. So why does it add res? So you don't need to reference assets in the file names. I guess. So it sort of implicitly knows that there's like a, I guess this is what it needs. Okay. Still adds res. Helpful. Did I not save that? Oops, it was here, wasn't it? Oh, was it model? God, I've lost the plot. Assets, not there. Assets. Hang on, what is going on here? Join res. Assets. Okay. That was... Okay, that's why. Great. Now what is it complaining about? System can't find the file specified. Why not? Space Calendar 37. Is it a PNG or a JPEG? Oh my god, it's a JPEG. Cargo run. Oh my god, what's wrong with this thing? PNG. Okay. Material 01. Material 001. Was that even a thing? Let's have a look. Cube. Oops, where was it? The zip file was here somewhere. Zip file? Let's have a look. Cube zip. Had no material stuff in it. Cube material. So what's it looking for? File name in load texture. File name in load texture is material 001. Where did that come from? Material. Lots of debugging. Where's material 001 coming from? Is it inside one of these? Let's have a look in here. Why is it trying to load material 001? Oh, it's that change that I made. There was a to-do, wasn't there? Can't remember what that was. Probably in model. Was it? Yeah, it was this. Okay. Load texture, material name. So it wasn't material name that we needed. It was material. So it's not name. It's so weird. So it creates these. So it gets a list of materials, loops through them all. These materials have a name. They don't have a file name associated with them. That's well and truly, file name's gone at that point. And so it's then trying to load a texture. So it's like what it's assuming that the material name and the texture is the same. Doesn't make sense. Well, I've got a crying baby here, so I'm going to probably leave it here and debug this another time. Let's just see if we can do this and just see what it does. It'll throw an error. Diffuse.texture. Found reference to option of string. So, let's have a look. Cargo run. Cube diffuse JPEG. Okay, I got past that. Now we've got an error in the pipeline. Render pipeline. Vertex buffer must be set to 1. Vertex buffer 1 must be set, sorry. Inner render pass, render coder, inner draw command, index true, indirect false. Vertex buffer must be set. So it's not here, it's the render pass. Vertex buffer 1 must be set. But we got rid of instance and vertex buffers. I wonder if we still need these, but we get it from wonder if we get it from the object model. Vertex. what's in the object model? Set vertex buffer 0. Index buffer. So no, we don't need that. So, but does it do instancing? It does, but there's no instancing going on in here. Instance buffer. Let's have a look. Vertex buffer 1, yeah. So it's like it's not setting up the instancing information. Instance buffer. So it's doing vertex and index. Set index buffer. Instance buffer. Instance buffer. And I got rid of this too, right? No, still got it. Oh no. Still got it. So maybe that's what's missing. We still need that. Perhaps. But we don't need the rest. I guess we'll find out. Let's try. If this doesn't work, I'm gonna give up at this point, or I'll just stop it for here. Okay, so something works. Oh wow, there you go. Okay, it does work. Woohoo, that's interesting. Cool. That's a bit of a relief if I'm honest. Wow, so we've got cubes now that are texture mapped with the depth buffer still working by the looks of it. It's kind of cool. Interesting. Well, and with the crying baby in the background, no less. So let's all right, so we're down here. We're at the point of using correct textures, and I'm going to stop here, just because I need to do some stuff around the home. But that was pretty full on. A lot of stuff to think about and kind of understand there, I think, and probably a fair bit of refactoring and cleanup to do. But before we close, let's just make sure that we've got everything that we need. So git status, we need to add cargo, builds, lib, model, and resources. And then what else do we need? I think that's about it. And then we'll do a commit saying refactored to load models, load geometry from a model file using tiny object or tiny whatever that's called, and added build to the to manage assets for the built. I don't know, during build. All right, and then we'll push. We'll just make sure that looks good. Probably not. We've got assets here, all there. Source, all there. Build is here. Cargo toml is there. Okay. And I think we've got everything we need. Lib main model, resources and texture. Okay, Wow. All right, folks, that's going to be it for today. Actually, let's just quickly go back and have a look here first, though. So we've got down to the point of loading models and the textures being written correctly to the models, and then we're going to modify this to do this last part later, do correct textures, and then rendering the entire models, whatever that means. And that'll get us to the end of beginner, which I think is pretty exciting. And then we'll then follow through on doing some stuff with lights and normal mapping, and see where we go. And learning a lot. So I hope you are too. This one was a little bit ad hoc and playing catch up with some of the work that I was doing off stream, but also with some other interruptions here at home. But feel free to subscribe and follow along. And if you have any comments, please be constructive and give me some comments below about what I could be doing better or differently. And we'll see you in the next one. Thanks a lot.